And I did the calculation for the outside diameter right here.
So we would just do the 1/4 pi, and what, 1.6?
Yes, 1.6. And then square it. If you want to, Madison, you can also take a look at my paper. This would be for the outside one right here. But that's gonna change our volume. And I haven't updated the volume or density, but how do you guys wanna communicate?
You would do like a group chat.
On what? Phone number, Snap, Insta?
We can do phone number if you want to.
Sure, that's fine.
We're just taking the inside volumes on this.
Yes.
Better. I'll put your number, I'll just create like a chat.
Yeah, it's 336-448-8854.
And then what's yours?
336-448-8315.
I'm just gonna send my name in it, and then if y'all
Good.
get it.
Yeah, I got it.
Okay. And so then we subtract.
Yeah, we take the 8.23 out of the 10.977. So that
I got 2.74798.
And that would mean that our density and percent error is going to change.
Yeah.
How did it say 2.7?
2.7.
For the volume.
Yes.
Do you wanna write it all out?
Oh, yeah, we gotta do significant.
Just do what?
We have to do the significant figures for it. I don't remember if it's noted or.
2.7.
Well, I was just,
5.8.
trying to figure out the.
Okay, well, at least we got that. We know that, so we'll know it'll change.
Yeah.
Appreciate it though, asking.
Oh, yeah, no problem. Dr. Bob. How much time do we have left in the break?
How much time do you need?
I was just gonna go grab a snack real quick.
Wait at the drink machine?
Yes.
Okay, yeah, you got time.
Okay.
Or,
Do you want me to eat out in the hole?
Oh, from a mass point of view,
Yes.
I might change my mind on this, but I've been allowing just, very quickly, you can move the mask aside, put the food in your mouth.
Okay, thank you.
All right. So for those of you, I don't know, it might be hard to believe, but those of you who can't read my handwriting. So we basically have a box. The problem starts out with the box is moving to the right. The frick bottom, do you need one to add one other part? Let's see. All right. So the problem starts with the box already moving to the right. As I say, the box starts moving to the right. Starts already. If on a test I happen to give some bizarre wording, then please make sure you ask. Don't suffer in silence. Make this my origin. And the right positive. All right. So at time A, the box starts out already moving to the right. B to C and G to H, and then I to J. The symbol right here, this is a mu, writing it a little bit bigger. The Greek letter mu is not equal to 0. This is to indicate that there is friction. When we actually get to chapter 4 and 5, why I'm using this notation will make more sense, but this is indicating that there is friction. So B, that time B, it's just before the box touches the frictioned section. C is just after the box leaves the frictioned section. C is also, when the box is at time C and time G, it is at the origin. D is the moment the box first touches the wall. E is the maximum deflection of the wall, or the farthest point to the right the box goes, and then F is basically the same as D, same position as it was at D. It's the last moment the box touches wall. Some people have issues with that one, of what's going on there. So imagine this is the wall, and here's my box. The box is coming in here. It first makes contact at time D. The wall will flex some, that's E, and then it starts to bounce back. And so that last moment it's touching the wall is time, what are we up to? Time F, and then it goes back the other way. So the wall does bend in some as the box hits it. And then, so F and D, the box is at the same point at those two times, C and G, B and H, A and I. And then I is the last moment before the box touches the friction section, and then it stops at that point at time J. Questions over handwriting or problem or any of that stuff? See, some people still writing down, so I'll give them a little bit more time, let people finish writing down. Well, some people are writing, some people are not, just throw out the question of why is to the right positive?
Because we want it to be.
Oh, yep. Yep.
What was that? I couldn't hear.
Oh, because we want it to be positive to the right. It doesn't matter if we put it positive or negative.
If I said to the left was positive, then, you know, all pluses and minuses would split, but other than that, it's arbitrary. Yeah, I think in one of the early tests, I forgot to actually indicate which way is the positive direction, so every solution had two different sets of answers. Then there's the unfortunate test where the origin, I identified two different locations as the origin. I knew what I meant. Unfortunately, no one pointed it out during the test. All right, so let's start working through it. Let's take the easy ones first. Well, the first three are the easier ones. Let's start out with position. I think it's easiest to identify where's position equal to 0. At what times?
G and C.
Say it again?
G and C.
Yep, good. Right there, I identified my origin at time, the origin at time C and G. So C comma G, or over on this chart, C and G. Where is the position positive?
Not including C to G.
Okay, not including either of them. So, yeah, once at time C, it's still moving to the right, and so it's on the positive side, it bounces and then still to the right of 0 until it gets back to G. So it's positive in between them. Or this display over here, not including C and G. And if we're right so far, everything else should be negative. And, well, everything is negative. Because it starts to the left of the origin to start with, and then after it passes point G, or time G, it's back in the negative region. So this would be A inclusive to C exclusive, and then G to J, including J. Some students will put the union sign there, because it's basically set notation. I'm flexible on that, you don't have to put the union symbol, but that's fine if you want to. Yeah, just seems cluttered. Notice we went from negative to positive by passing through 0, and we went from positive to negative passing through 0. All right, displacement. Where's displacement? 0.
A and I.
Yeah, that's the beginning of the problem. So that's A, comma, I. And where's the positive?
From A to I, but not including them.
Yep. And the others are negative. So A to I, not including, and then I to J, including J. Where's the velocity 0?
Is it D or E? When it hits the wall.
D is still moving to the right because the wall flexes.
So it'd be E.
E. That's the turnaround point. There's one other point where it stops, where it is stopped.
J.
J. When is the velocity positive? Is there a new voice? Through D?
E.
E. Yeah. And if you said A through D, if you're filling out this way, you got plus, 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 then you'd have a gap there, and at that point, you would then hopefully realize, oh, it's still moving to the right. And then, so A is included because it starts out already moving. E is not included because E's over here, and then over here, E not included, J not included. All right, questions up to there before we tackle the tough one. All right, so, a tough one. It starts out moving to the right. I don't know how fast it's going, but let's just say it starts out going to the right at 15 meters per second. What's going to cause the speed to change?
Friction.
And,
The wall.
yeah, so friction and the wall are the two things that are going to add forces, add a net force to it. So from A to B, there's no friction in that region, and there's no wall, so it should be going the exact same speed, same velocity. Then it's going to slow down. Because if you throw something, take any box, slide it across the floor, it will slow down. So it's now a slower value, so negative 10 there. And I'm going to erase the line below it just to, I'm not saying that's not true anymore, I'm just giving myself some space here. So I started out, I'm making up a number here, positive 15 because there's nothing to slow it down. I have friction here to slow it down, positive 10. What about at time D? Yep, because there's nothing to slow it down in that region. And then at E, we know it's 0.
Yep.
What about at F? It does. What would the velocity be at F? Say it again? Not that much. Unless it's made of rubber. That would be the speed. What's the velocity? The difference is the direction. If you just said, if I just wrote down 10, that doesn't tell me the direction.
Oh, -10.
Negative 10. At G, there's nothing to slow it down from F to G. So that should be negative 10 again. It slows down again, going to H because it hit friction again. So it slows down, so let's say negative 5. H to I, there's nothing slowing it down. And then at J, it stops again. So, what I'm basically doing here is looking at the way of looking at the acceleration in a slightly different way. Because remember that acceleration is the change in velocity over the change in time. So whatever the sign of change in velocity is, it's going to be the same sign as acceleration. So when I go from A to B, what's my change in velocity?
There is no change.
Right, my change is 0. Let's get a different color just for that, the typical stunning visual effect. So my change is 0. This is my change in velocity. What about from B to C? What is my change?
-5.
Yep. What about from C to D? D to E?
-10.
E to F? I couldn't, I can't. Not-
-10.
It is negative 10. This change is always final minus initial, so it's negative 10 minus 0. Or that's negative 10 there. F to G?
0.
G to H?
-5.
Negative 5. Whoops. Negative 5 minus negative 10 is negative 5 plus 10, or positive 5. H to I? I to J. Yep. So my acceleration, I know between A and B it is 0. We're gonna go back in and fill in the other parts, but I'm doing the in-betweens. Between B and C, it is negative, and then it is 0. Up to there. And then it's negative again, and it's negative again, and it's 0, F to G, that's this right here. Then it's positive, 0, positive. Now the only things that are going to affect it are friction and the wall. That will cause velocity to change, that will cause acceleration. B, it's not touching the friction yet. So from A to B, including them, it's 0. Because it doesn't touch friction until just after time B. C, just after the box leaves the friction area, so it's not in the friction area at time C. D, it's touching the wall.
0.
I thought the wall could affect it. The wall will cause it to speed up or slow down, so as soon as it touches the wall, that's causing an additional force that causes acceleration. So D is actually negative. E, it better not be 0. Sure as heck won't be positive because I'm not going to jump from negative to positive without going through 0. And it can't be 0 because that means the velocity won't change, and we know it bounces back. That's negative. And F, it's still touching the wall. G, it's not touching the friction section. H, it's not touching the friction section. I, not touching the friction section. It's just before it touches the friction section. And now J is positive. If J is not positive, that means it still has some velocity, a non-zero velocity. Because J is that moment it stops. The moment after J, the acceleration is 0, but at J, it's that last, actually the last moment when there's still acceleration. And so this is positive from G to H, and I to J, including J. And then 0, A to B, including both of them. And then C to D, includes C but not D. F to G. And then H to I. And then negative and then D through F, including them, and that's it. Let's confirm some things here. I know that when velocity and acceleration are opposite signs, it will slow down. Well, where does that occur? Velocity and acceleration are opposite signs here, 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 here. So between B, time B, and time C, does it slow down? Well, it's going across friction area. Yes, it's slowing down. From D to F, D to E, is it slowing down? Yeah, because that's when it first touches the wall to the point where it stops. From D to H, well, that's when it hits the friction section again. It's slowing down. I to J, yeah, it's slowing down because it stops. It has to slow down to stop. From a force point of view, looking at the same thing. It's cruising along, minding its own business. Suddenly it has friction here. Friction hates motion, it always opposes it. So if the box is going that way, friction is going that way. So friction is negative when it's going that way across the friction section. Acceleration is negative when it's going that way across the friction section. When it hits the wall is pushing on it that way. It first slows it down and then pushes it backwards. So while it's touching the wall, the net force on it is that way, negative. Hit the friction section again. The box is going this way and friction hates that, so friction tries to push it that way. Or pull it that way, however you want to look at it. Well, that's the positive direction. So friction, and therefore acceleration, positive. And then I to J again, the box is going that way, and friction hates that, and so friction is trying to make it go, is pulling it back in the positive direction. That is a Tesla level problem. So just letting you know, most likely the last question of the test is one of these, of the first test. It will not be this one explicitly, but it will be something along this line. If you look at old tests, you'll go near the end. You should see something like this. The earlier tests, I think I vomited air problems. Then I just went crazy. Questions? Brandon?
So, would you, I guess, if you'll say, ask us to make either chart expressing all of that?
What I do is I set up the problem, so usually it takes a page to do the drawing, do all the text, and basically set up the problem. You turn the page over, and I've got, more recently, 4 different ways of expressing the answer. You pick the one that you want to use.
So you have those?
Yeah, I already have the charts already set up.
Perfect.
Yeah, I'm not gonna, it takes long enough to set it up without the time pressure.
Yeah, okay, perfect.
Other questions right now? There's also a PowerPoint that is posted under probably chapter 2, where I go through step by step something like this. And then the very last page will be sketchy graph of the motion. So let's do that over here. So I got my position versus time. The inferior marker. No. There we go. That's faded that much. There we go, that's the new one. Now, the graphs I already have set up displayed, and I've got it marked off in even increments of A, B, C, D. Actually, I know some tests I haven't marked off, and other tests I just have the hash marks on there, and I say put in the letters. I can't remember what I've done most recently on that. A, B, C, D, E, F, G, H, I, J. Ideally, those are lined up. All right, so I know that the position starts out negative, hits 0 at C, so let's go ahead and mark my zeros in. Those are the easy ones we can do. And G, it is 0. My velocity is 0 at E. And J. And my acceleration is 0 from A through B. And C and D, not including D, so this would be A, B, C. And I'm gonna stop my dark line just before D hits. And then F to G, not including F. And then H through I. Now I recommend that